So I'm Justin Brown with J Educational Products, and this is our third and final design phase for our BRG. This is the one where we completely built our prototype and tested it.
So I'm Austin Victor, I'm the second member of our group. So for the last few weeks we've been working on product architecture, industrial design, and design for manufacture, and we've also been doing a more in-depth economic analysis on the cost of our BRG and how that will affect the results or the future of our product. And we've also been prototyping, which will give us a greater idea of what our BRG will look like in person, and that's been really helpful for us, and we've been doing that for about 2 weeks now, and then we're finally able to present the final results this week.
Hi, my name is Ivan Zhao, and speaking of the product architecture, the BRG product can be divided into 5 chunks, which are platform, station 1, station 2, station 3, and user interface. Each of the 3 stations are connected with tracks, so it's relatively easy for the user to add more stations to the BRG, as long as the ping pong ball can touch the trigger to initialize the station 1. And the servo motor in station 2 is connected to the user interface trunk with wires. So servo motor connected to the breadboard, and breadboard connected to the Arduino, which is run on the computer. Well, speaking of industrial design, the overall quality of the BRG product is pretty good. In general, the BRG product was easy to use and good for demonstration. For most of the time, the BRG product can transport a ping pong ball across the board successfully, and is super safe to use for educational purpose. And it demonstrates physics concept very well. The only thing the user needs to do is to turn on the battery of the conveyor belt when the ping pong ball enters the second station. However, the setup time is pretty long. It could take up to 30 seconds to reset the BRG after each run. Besides, even though the emotional appeal is not quite important for educational use, the BRG product is very nicely finished. Well, the BRG product is pretty easy to maintain and to repair, since it used adjustable straps for most of the parts in station 2, especially the conveyor belt. Even though the bow in station 1 is unable to repair, it's quite reliable and is not that easy to break. Moreover, the BRG product uses eco-friendly materials such as wood and cardboard. Finally, the trigger used in station 1 is pretty unique. However, since the BRG product demonstrates physics concepts only, so it's unable to get rid of ramps.
So our final BRG is made up of 6 different parts. We have the station 1 bowl, the entrance ramp, the ramp that goes underneath the bowl, the connecting piece to the conveyor belt, and the final ramp. The way that our BRG works is the ball rolls down a ramp and bumps the trigger that's on the entrance ramp. That nudges a ball that's sitting on the edge of the bowl around the loop, which shows centripetal force. When the ball falls through the hole, it rolls onto the ramp, over the connecting piece, and to the conveyor belt. That's when the student will turn it on. The ball will roll up the conveyor belt to the top, and when it reaches the top, it'll fall down the chute for the ramp and launch at the bottom. The students will be able to change the angle at the bottom of the ramp and calculate launch speed and final distance. So during our testing and refinement, we had to make small adjustments to different heights and angles to allow the ping pong ball to flow more fluidly through the BRG. Next, we're going to do some more stress testing and strengthen components that we feel could possibly break if they're mishandled too much or something like that. And finally, we're going to create casts and make the different components out of plastics and other materials to make it more of a final consumer product.
So this is our assembly time worksheet. It shows a breakdown of the time that it takes to complete operation to assemble our final BRG. We used the Boothroyd-Dewhurst tables to get an estimate on what the time it would take to manually handle the part, and also the manual insertion time for each part. So the first part that takes place is putting the entrance ramp onto the pegboard. After that, we place the bowl into the pegboard. These two operations don't take that much time because there isn't like too many obstacles that you run into when placing these two items. But the one tricky part after placing the bowl is putting the ramp underneath the bowl. It's a little tricky to get that in place because you have to worry about the obstacles of the entrance ramp and the bowl. After that, you have to place the pathway connector that connects the ramp under the bowl and the conveyor belt. That's pretty easy too because there isn't many obstacles in the way. It only takes about 2 to 3 seconds. And then next we'll have to assemble the conveyor belt. So first we'll have to insert the wooden dowels inside the paper rolls, and so that way those are what turn the that's what the motor is attached to that turns our conveyor belt. And then next we'll have to attach the fabric that we use for the conveyor belt around these two paper rolls. This whole process takes a lot of time because it's not just putting it on the board, it's actually like assembling it kind of like in 3D almost. And then next we'll have to place two cardboard pieces that are shaped like L's between the two rollers to keep them from moving. The next 3 steps won't take too much time. We just have to place the conveyor belt onto the board at the end of the attachment that connects the conveyor belt to the ramp under the bowl. And next we'll have to place the servo stand that we created onto the board next to where the wooden dowel sticks out of the conveyor belt. And then we'll have to place the motor inside the stand. These operations only take about 3 seconds, so it won't take up too much time for assembly. But what does take up a lot of time is trying to use wires to attach the Arduino to the wooden dowels. This takes about 17 seconds, and it also takes, so what takes up the most time is setting up our Arduino. It takes about 80 seconds, we estimated, just because there's a lot of little wires that are very small and it's easy to make mistakes when placing them in the board. And then next, which is probably one of the most easiest parts of our Arduino to assemble, is placing the exit ramp at the end of the conveyor belt so that I can exit the pegboard at a reasonable speed. So this is a CAD video that we made that shows how to assemble our BRG. It's easier than me explaining it in total, so I'll let the video play. So this is a cost sheet that the team came up with. It gives a list of each of the materials that we use to build our BRG, and it gives the cost estimate about how much each of the materials cost. Some of the most cheapest materials that we used were cardboard and the wooden dowels that we used to keep all the parts in place. But the most expensive part was probably the pegboard, paper rolls, and especially the foam bowl that we had because it was already had been manufactured to a farther point than most of the other materials. And then the assembly cost from the last few slides was about 82 cents total per BRG. It's not too bad, but the total cost to build our BRG was about $28, which is relatively low, so that we can still sell it at that price of about $50. Overall, the team is very proud of the accomplishments that we've made within the past few months. We were able to create a very successful BRG, one that I didn't think was even possible, but overall we're very proud. And in the future, we hope to decrease our manufacturing costs so that we can sell the product at a lower cost, which will increase our market to more underprivileged kids so that they'll be able to learn these physics concepts in a fun way too. And with that, we want to ramp up the production on our product so that way we can give it to more people in the future.